My name is Mr. Koda, and I want to talk to you a little bit about balancing chemical reaction equations. But before we begin that, I would like to review just quickly something that you've seen before, a chemical reaction equation, and talk to you about some of its parts just briefly, and then we'll get into balancing it and what balancing means. On the board behind me, I have a chemical reaction, and as you remember from last week, a chemical reaction has reactants. These are the compounds that are on the left side of the arrow. And it also has products, and in this case we've got one single product. And the reactants in this case are hydrogen gas, H2, and oxygen gas, which is O2. And as a product, those two items combine, those two compounds combine, and they form water. And one of the things that I'd like to point out here is you do know that the plus means and also the arrow indicates produces or yields or reacts to form. And let's take a look at this chemical reaction because it's not yet balanced, and one of the things that we want to teach you is how to balance and what balancing is. So let me come over here and let me grab a couple of blocks. I use these occasionally in demonstration purposes, and let me show you. I have two blocks that are connected together. They come apart, and in fact on one side I've put a little bit of tape. And each of the blocks here, each of the two blocks, are supposed to represent a single hydrogen atom. So I have a hydrogen molecule here, and you'll notice that I'm going to put it right here. And I'm going to also take an oxygen molecule, and here's my representation of an oxygen molecule. I've got two blocks. These two are also put together. A little bit of tape on that side. And we're going to put our oxygen molecule here. And I want you to imagine that a chemical reaction equation indicates 2 points in time. And one of the points in time is the before, and I've represented the before here with our hydrogen molecule and our oxygen molecule. So we're going to imagine that time goes by, the chemical reaction occurs, and so let me show you what should be happening. We should be taking one of these oxygen atoms, and this oxygen atom is going to, let's pull the tape off here, this oxygen atom is going to combine with our two hydrogen atoms, and put that tape back on. And now later in time, I have my water molecule. But you'll notice that I still have an extra oxygen molecule. And as our chemical reaction is written up there on the board, we have not accounted for this. This is kind of lost or thrown away, and we don't want to do that. Now, if this is the situation, we do not have a balanced chemical reaction equation. We'd like to have one. And so we're going to talk to you about how to use some numbers to make sure that your chemical reaction is balanced so that we don't lose this oxygen atom. All right, let me give you the technique. Let me set these aside. Let me move this off the board. And here's where the technique begins. I want to give you a mnemonic. The mnemonic is this: M, N, O, H. M-N-O-H can be remembered by my niece owns horses. And each of those four letters represent these words. Metals for M, non-metals for the N, oxygen for the O, and hydrogen for the H. So what I want to do is, in order to balance this chemical reaction equation, I'm going to make some changes to it. Now, the only changes that I'm allowed to make are changes to the coefficients, or the numbers that are in front of each of the compounds. Now, as you look at this chemical reaction, you see that there are no numbers in front of each of the compounds, and so if you don't see any, we assume that it's 1. So in this case, I've got a 1 in front of my H2, I have a 1 in front of my O2, and I have a 1 in front of my H2O. But again, as we saw before, it's not balanced. So we're going to go through a set of steps to get this balanced, and by doing that, we will have changed some of the coefficients. Well, let's start with metals. So the first thing you want to do when you balance is you want to balance your metals. That means have the same number of metal atoms on the left side of the arrow as you do on the right side of the arrow. Well, this happens to be a chemical reaction equation where we don't have any metals. So we can go ahead and put a check mark here to say that indeed they are balanced. So as we finish with each of these steps, we want to go to the next step. And so since we are done with metals, we're now going to go to nonmetals. And initially you might think that oxygen is a nonmetal because it's high and to the right on the periodic table. That makes sense, and oftentimes we do consider it as a nonmetal. But in this case, oxygen has its own rule. So we're not going to count oxygen as a nonmetal. And also sometimes you might think that hydrogen is a nonmetal. It is on the left side of the chart, but sometimes we slide it over to the right for certain reasons. And in this case, hydrogen too has its own rule, so we're not going to consider hydrogen as a nonmetal. So oxygen and hydrogen are off limits for categorizing them as nonmetals. So in this case, we've got H and O, and there are no nonmetals according to our definition. So we're going to put a check mark here, and we're going to say our nonmetals are balanced. That we have the same number of nonmetals on the left side of my arrow and also on the right side of the arrow. And so we're checking through these rather quickly, but we are going to run into oxygen here now because I want to balance oxygen next. I want to make sure that the number of atoms for oxygen on the left side of the arrow match the number of oxygens on the right side of the arrow. And if you look at this carefully, you see that this is not true. I have 0 oxygen atoms right here. I have 2 oxygen atoms right here, but I only have 1 oxygen atom here. So this causes a problem. And what I want to do is I want to change the coefficients so that my oxygens match. And if I change this coefficient right here, and let me pause for just a moment. When we add the coefficients in, we want to make sure that they are whole numbers. So I'm going to change my coefficient, which is understood to be a 1 right there, to a 2. And if I make that a 2, I now have 2 oxygens on the left side of my primary arrow here. And now, because of the coefficient here, I also have 2 oxygens on the right side. I can change this to a 2. And now my oxygens are the same on both sides of the arrow. They are now balanced. Now for a point to remember. I may have balanced while going through MnOH. I may have balanced my oxygens while I'm doing the oxygen step. But I also may have made a different count, or messed up, if you will, one of the other steps. This is okay. As long as you're working on the current step and you get that balanced, as you go through the process, the others will balance themselves. So watch. I'm going to put a little check mark next to oxygen. We're going to say our oxygens are balanced. We don't need the 2 here. We don't need the 2 here. You will see that my hydrogens, however, because I've added that 2 coefficient there to balance my oxygens, my hydrogens are now no longer balanced. I have 2 hydrogens here and 2 times 2, or 4 hydrogens on the right side of the arrow. So that's going to be a problem. But I'm not yet at the hydrogen step. I'm just a moment away. So let me actually go to hydrogen, our last step in the step of 4 here. And let's do that count. I've got 4 hydrogens here, and I've got, I only have 2 hydrogens here because my coefficient is understood to be a 1. And how do I get 4 hydrogens over here if my right side has 4? Well, put a 2 here, and you'll see that I have 2 times 2, or 4 hydrogens on the left side of my arrow, and they match up now with the 4 hydrogens on the right, and I can put a check mark here. So I've now gone through my 4 steps. Here's what you do after you get through those 4 steps. You start again. In fact, the last step or last cycle that you should do is the one that checks to make sure that you are still balanced. So I think I'm pretty close to being balanced, so let's see if we can do that check. Let's go back to metals again. There aren't any, so we're going to put our check mark here. Metals are still good. Let's go to nonmetals. There aren't any nonmetals as far as we're concerned because remember, hydrogen, oxygen, they're not nonmetals as far as we're concerned. Oxygen has, well, let's count. It's got 2 oxygens here on the left side of the arrow. It has 2 oxygens on the right side of the arrow. That is still good. And if we look at hydrogen, we have 4 on the left, 4 on the right. So this looks good. So this is the primary method that I would like to teach you on how to balanced chemical reaction equations. Let's go through a couple of others. Let me erase this, and let's see what else we've got here. Take this out of the way. We'll erase our check marks. We're going to leave our MNOH up there on the board. Let me remind you again, my niece owns horses is the mnemonic that I use to remember metals, nonmetals, oxygen, and hydrogen. Okay, let me take a look at this. We have this actually is a metal, aluminum plus, and I have iron 2 oxide, and this is going to react to form, let's see, Al2O3, which is aluminum oxide and some iron metal. Put a plus here, and this is our new chemical reaction. We're going to take a look at this, and we're going to follow these steps in order to balance this chemical reaction equation. So let me start. Let's start with the metals. Last time we didn't have any metals. This time we have actually 2. And so the question becomes, well, which one do you do first? Usually you just pick the one that's further to the left and do that one first, and then you would go to the next one. So in this case, I've got aluminum on the left, and then the next compound there that's a metal, the next element that's a metal is iron, or Fe. So let's do our aluminums. Now, take a look at my reacts to form arrow. The compounds that are to the left of that, I need to compare the atoms to the right. So on the left here, I've got 1 aluminum. On the right, I've got 2 aluminums. I'm going to change the coefficient in front of that aluminum to make it 2. And now my aluminums are balanced. But remember, we're not going to skip our metal step and go to nonmetals until both of the metals are balanced. Well, let's take a look. My next metal is iron. And I have 1 iron atom here. I don't have any right here. So on the left side of my arrow, I've got 1 iron atom. On the right side, I have 1 iron atom. And that looks good. And because aluminum and iron are now both balanced, we have the same number of atoms on both sides of this arrow, I can put a check mark here on my MNOH checklist. Now, let's go to nonmetals. Now, if you remember last time, nonmetals don't include oxygen. The only other element we have here is oxygen, so we can go ahead and put a check mark on our nonmetals. Now we're at oxygen. Now, I have, well, let me start on the left side. I don't have any oxygens here. I've got 1 right here. On the right side, I've got 3 total oxygens, so I need to get my number of oxygens up to 3. And so let me put a 3 right here. And you will see that I've got 3 oxygens on the left, 3 oxygens on the right, and I can put a check mark here. Now, let's go to our last step, hydrogen. There is no hydrogen in this chemical reaction equation, so I can go ahead and say that it is balanced and put a check mark. And if you remember from our last example, I went through the MNOH checklist once, and then I had to go through it one more time just to make sure that everything was balanced. Because sometimes it doesn't end up being that way. So let's do a check here. I have 2 aluminums and 2 aluminums. That looks good. I have 3 irons, and I don't have 3 irons on this side, so I still need to run through my list here and make sure everything is consistent. Well, it's pretty easy to make sure that my iron is now balanced at 3 and 3, and so I can say my metals are good again. And again, I don't have any nonmetals, so I can put my check mark here. Now, because I've made a change in that sequence, let's see if oxygen changed. It may not have. And if I look, I see I've got 3 oxygens here and still 3 oxygens there. So the oxygen did not change. I can put my check mark here. And again, there is no hydrogen, so my check mark is there. Now, in that last sequence, I did make one change to the iron. So let me run through it very quickly, 1, 2, 3, 4, and see if there are any changes. No changes to the aluminum, no changes to the iron. There aren't any nonmetals. My oxygen is still 3 and 3, and there is no hydrogen. Your chemical reaction is balanced. All right, let's try another one. Let me erase the board here. This last one here, a little bit tougher, a couple more cycles. Let's see if we can get this out of the way. And we're going to get rid of our check marks here on the MnOH. And let's see what we have. We have, actually the charge on this changes. It's kind of a minor detail, but we have FeS2. This is iron 4 sulfide. And it's going to be combined with some oxygen. And this is going to react to form some iron 3 oxide. And the other product that we have there is sulfur dioxide. So we're going to do SO2. So this looks a little bit more complicated, maybe. I'm not sure. Let's see what we're going to do. Again, we're going to try to balance this chemical reaction equation, and our balancing is going to begin with MnOH, and we are going to start with metals. And we're going to take a look and find our arrow here. We're going to compare the number of atoms on the left side of the arrow with the number of atoms on the right side of the arrow. And we are going to start with metals, and I see that we've got one metal here, which is iron. I have 2 iron atoms on the right side, 1 here on the left. Let's put a 2 right there, and we'll make sure that our coefficient changes to a 2. And I think we can put a check mark next to our metals. So here's my check mark next to the metals. Now let's do nonmetals. And here's a case where we actually have a nonmetal, and the only nonmetal that we need to be concerned about is sulfur. Again, oxygen has its own rule. And sulfur, I have 2, at this point, I have 2 times 2 sulfurs, or 4 sulfurs here, and only 1 sulfur here. Now, let me stop and just make a very minor point. In the prior step, the step with the metals, I had changed this coefficient. Once I get to the non-metal step, you don't want to get rid of this coefficient. It's already there. You've already placed it. You need to use it to do your calculation on the number of atoms. So here I've got 2 times 2, or 4 sulfur atoms. On this side, I need to put a 4 right here in front to match up my sulfur atoms. And now I can put a check mark on my non-metals because there aren't any besides sulfur. Next step, oxygen. Now, another little nuanced step I want you to be aware of. If you see on the left side here, this oxygen here, it's got a 2 right there. That means whatever coefficient you put in front of that, the number of oxygen atoms is always going to be even. If I look on the right side and I see that I have 3 oxygens right there, I need to make sure that I have an even coefficient here before I do any balancing of oxygens. So one of the things I need to do is be aware of that. If I see that 3 right there, I'm at a very initial step. I'm going to have to put a 2 here, because that's going to give me a total of 6 oxygens right here. And I have 4 times 2, or let me squeeze this in here. I have 8 oxygens there. So I have 6 plus 8 oxygens on the right side. That gives me 14 total oxygens. And if I put a 7 in front of this, I can get 14 oxygens there. If I had not done this step, I would always have an odd number of oxygens on the right. This would never work. So by doing that little trick there, I can now get my oxygens balanced, at least as an interim step. Now I want to pause for a moment. I want to pause for a moment because there's a very important thing that starts to happen when you have chemical reaction equations that you start to think are complicated. If they are complicated and you are following through the different steps, there usually will come a point, if you're not really comfortable with balancing, where you'll start to panic. So what I want you to do, I want you to hold on to that panic and not let it get a hold of you, because as you go through, each step will fix itself as long as you have some patience. So I start to see, wow, we're starting to get quite a number of oxygens. I'm doing a little bit of panicking here, but let me stick with what it is that we're trying to go through on our steps. So I finished oxygen. Let's go to hydrogen. I don't have any hydrogen, so that's good. So let me put a check mark here, and we're going to go back to our metals. Now let me take this out of the way because we don't need it right now, and we're going to compare our metals. Now here I've got 2 iron atoms, and so 2 on the left side, but I have 4 on the right side, so I need to change this. Now you'll see I'm going to make this 2 now a 4, and my metals are balanced, but I start to have that little fear because I start to think that wow, now I'm changing my S's and I might be messing up something else. That's okay. That's okay. Just do whatever step you're currently working on. Keep your check marks there. And our metals right now, our only metal, iron, is balanced. We've got 4 and 4. Next step, nonmetals. There's only one nonmetal, that's the sulfur. Now here I have 4 times 2, or 8 sulfurs. And in order to get this to 8 sulfurs, I have to put my 8 here. And we're going to put our check mark. And you see the numbers start to go up, and you might start to worry, but don't. Now, let's do our oxygen again. Now, I have 2 times 3. I have 6 oxygens, an even number there. That's good, so I'm going to write my 6 there again. But now I've got 8 times 2, or 16 oxygens there, for a total of 22. Now, I need to change this. Patiently change that. And I need 22 oxygens out of this. So if I put an 11 in front of this, here's my 11. And now I have matched up my number of oxygens on the left with the right, and I can put a check mark here. Let me get rid of my numbers here just to clean up the board just a bit. And now let's do hydrogen. Hydrogen's easy. Let's go back through one more time. Let's see if we've balanced everything. We may not have, but we need to check. Metals, I've got 4 irons. 4 irons, that looks good. Nonmetals, well, I've got 8 sulfurs on the right here. 8 sulfurs. And I've got 4 times 2, or 8 sulfurs on the left. That's good. So sulfur is done, and nonmetals are done, because sulfur, again, is the only nonmetal. We're going to check oxygen one more time. 22 oxygens right here. 2 times 3 gives me 6 here, plus another 16. I've got 22 on the right, so oxygen is still good. This looks like it's going to be my last pass, and in fact, it is my last pass because there's no hydrogen there. So what we've done is we've given you a little background on making sure that you have a balanced chemical reaction equation, or figuring out what one is by making sure the number of atoms on one side of that arrow matches the number of atoms on that side of the arrow, and then giving you a technique on how to go through it. MNOH, metals, nonmetals, oxygen, hydrogen, and hopefully this gives you enough background so that you can balance any chemical reaction equation that comes your way.